All right, guys, we're going to get started. The date today is the 4th of March, and the topic today is on the screen, dimensional analysis. So, guys, let me get you caught up, and then before we even start figuring out what on earth this means, we need to have a little family meeting. So, you guys, you're caught up with me, right? Okay. So, guys, here's the thing you've got to understand. What we're going to do today, and please hear this, what we're going to do today is you are going to learn a problem-solving process to solve what are probably the dumbest problems you've ever solved in your entire life. If you don't get into the middle of the homework today and get frustrated with me, you're not actually actively engaged in what we're doing. Guys, very quickly as you get into the middle of the homework, you're going to be thinking to yourself, why is he wasting my time? I don't care about the answers. I can do this stuff in my head. This is so absolutely stupid that I'm just done because it's a waste of my time. But then, guys, here's the problem. Tuesday is going to come along, and all of a sudden, it's not going to be easy. And it's not going to be meaningless, and it's not going to be stuff that you're going to be able to do in your head. And at that moment, there is going to be a separation in this room. And the line that will divide you is going to be measured by the trust that you have in me. For those of you that trust me and believe enough in what I'm doing with you that you're going to go home this weekend to do your homework, and you're going to have that thought, this is stupid, but then you have the additional thought that says, Knappenberger told me it was going to be stupid, and I'm going to do this because I trust him. Guys, Tuesday is going to be an amazing day for you. But for those of you that go home over the weekend and you have the thought, this is stupid, and then you have the additional thought that says, I don't trust Knappenberger, I don't believe in what he's doing, and I'm going to choose the path of least resistance because I'm not going to invest the time to do things that immediately seem stupid. Guys, Tuesday is going to be a disaster. And what you're going to end up having to do is go back and reclaim the stuff that you didn't do as a result of today so that you can figure out Tuesday. Because, guys, what I'm going to do is I'm going to start throwing a bunch of really stupid questions on the board. And through this process, we are going to figure out how to solve these problems. But, guys, the big idea is this. We don't care about the answers. We care about the process. And, again, you're going to be able to do this stuff in your head. But that's not the point. The point isn't the answer. The point is the process. Because what we're going to do on Tuesday is we're going to take that process and we're going to apply it in a setting where you can't solve these in your head. Do you understand what I'm saying? Can we together choose to trust so that you're going to have a great day on Tuesday? Is that okay? Okay. So guys, how stupid does this get? Ready? It gets this stupid. How old are you in seconds? Who cares? Do you care? I don't care. Do you care? But would you figure it out anyway? Guys, pencil, paper, and calculator, figure out how old you are in seconds. Do it. Don't talk to anybody. You'll have a chance to talk in a minute. But guys, figure out how old you are in seconds. Are you raising your hand because you care? Yeah. Actually, all right, here. I find that phone calculators are worthless. Hey, so guys, hold on. I'm going to go back on what... Don't talk to anybody, please. If you start conversing about this... Matthew, I need your feet facing south. If you start to talk about this, you're going to lose the moment. Do it on your own. So, guys, can we have this conversation for the last time? You're going to bring calculators to class, yes? Okay. Don't be scared. Anyone else? Good. Guys, the thing that's funny is while you guys are toiling away figuring this out, all I can think about is Tuesday. Because Tuesday is probably my favorite day in general chemistry. What I meant to say was Wednesday. Shoot. Do you ever get the sense that the people at the school board have just done everything in their power to absolutely destroy our schedule this year? Like, if you set out to make a bigger mess of our schedule, I don't think you could do it. It's unbelievable. Matthew, what'd you come up with? Actually, wait, how old are you? 18. What'd you come up with in seconds? Then get to work. What? Is it hard? All right, go ahead. 52. Go ahead. No, because that would be learning, and we don't do that here. We just want to have good experiences and make you feel good. Guys, you're going to find at the end of the quarter, I go in one of two ways. I either retreat to anger or sarcasm. I think this is going to be a sarcasm year. So you're either going to get angry Knappenberger or sarcastic Knappenberger. So we're going to go with sarcastic. No, I aspire to be angry Gil. Yeah. He brings it. Okay, guys, you've got about 10 more seconds to come up with a number. You need you all to have a number. Oh, we're going to talk about that. We're going to talk about that. Okay, so guys, we're going to wrap up the process whether you arrived at a number or not. But I need to ask you a question, and I really do need to see hands. How many? Is anyone in the room 15? Really? Awesome. 16. Show me. Hands. 17. We're split, but 17 appears to be the most predominant. And then 18. Anyone else? 18? Okay. So guys, we're going to say that we are, well, never mind. We'll do that in a minute. I just needed to know. Guys, here's what I want you to do. You're probably sitting next to somebody that's not the same age as you, and therefore your answer will be different than theirs. But again, guys, we talked before, we don't care about answers. What I want you to do is this. Explain to the person next to you, and yes, Matt, you can talk to Joe. Explain to the person next to you how you came up with your answer. Again, even if your answers are different, would you please talk process with the person next to you? It's going to work. "30 seconds, y'all." Can I? Ten more seconds. All right, guys, let me pull this together. So, if I may, I was eavesdropping heavily as you were talking, and guys, I heard some really interesting and insightful things. Let's start with the thing that we all heard, which was Ami asking how many weeks are in a year. But then, guys, I heard a lot of shared thoughts, terms, ideas. I heard people talk about "then I multiplied." And I heard people talk about, they actually said this, and then I, and then I, and then I, and then I. And guys, when you say things, and Abby and Jesse definitely had that conversation, when you have this conversation about, and then I, and then I, and then I, and then I, what you're talking about is process. And guys, as you were having these conversations, Cale apparently is a hand talker, because as he was talking with Michael, do you even know you do that? You talk with your hands, and I love it. That actually means you could be a good teacher. And so, guys, we find, we actually find that there's a link between the animation that you put into the way you talk and just relative intelligence. It's interesting. Smart people talk with their hands. And so, don't let it go to your head. But guys, I know. And actually, it's funny because Kimball was actually he was like poking his screen of his calculator, like, and then I did this, and then this. It almost got violent. But guys, this is what I heard. I heard process, I heard math, but then I heard all these interesting little nuggets about how many weeks are in a year and 60 seconds in a minute. And somebody was talking, I think was it you guys 24 hours days? You went day? I heard these guys talking day. So guys, here's the thing. If you were listening as I was listening, what I found is that all of the pieces were there to be successful in solving this problem. But what I also found was this. There was chaos in the midst of brilliance. That all of you were headed in a positive and productive direction. But guys, I would propose to you that if the process that you just engaged in is the process that you need to use to solve problems like this every time, you're going to run out of time. So guys, here's what we're going to do. Don't miss this transition. Guys, what we're going to do is we are going to make sense out of the chaos. David, we are going to provide you a way, and understand we don't care about how old you are in seconds anymore, so David, be with me rather than Josh. Guys, what we're going to do is this. We are going to take all of the great things that were going on in this room, and we are going to organize them in such a way that we all can be equally successful. And guys, that's all dimensional analysis is. It's the process of organizing the very things that we're talking about. Now, guys, at this point, we need to be clear. This is what I started the day with. Guys, we are going to organize things that you already can do, right? But guys, quickly next week, what's going to happen is that organization is going to allow you to do things you can't do. But right now we're worried about process. So guys, what I want to do is I want to share with you this process. Write this down. How do we organize this process? And guys, the answer is we are going to apply a series of steps. Step one is this. Please only write down the underlined terms. Step number one is you are going to determine a goal. In the words of everybody's favorite Provo-based motivational speaker, start with the end in mind. Who's that? Stephen Covey, Britain, his boy, anyway, it doesn't matter. All right, number two, determine a starting point. You guys don't even know about that thing about the 7 habits of highly effective people? Yeah, see, that's Stephen Covey. His boy plays at the U. He's like 4 feet tall and runs like a street. Yeah, anyway, all right. So guys, number 2 is this. Starting point. Just write down starting point. Number 3, draw a line. For me, this is the hardest part because I'm a left-handed guy and my handwriting's horrible. Number 4, conversions. But guys, along the way, there are 2 things that have to be true of these conversions. Don't try to make sense of it. I'll explain it in a minute. Guys, these conversions have got to be fractions that are equal to 1, and they must cancel. Please, again, only write down the things that are underlined and bolded. The units must cancel, and that'll make more sense to you, but the idea is they cancel in such a way that it leaves you with your desired answer. Then guys, step number, am I going too fast? I'll slow down. Okay, step number 5, solve. Now guys, as we solve, we will multiply by everything on the top. You could just write down multiply top. We will divide by everything that's on the bottom. Then gang, there's one more step left. You will round your answer to the least significant digits. You could just write down least significant digits. So guys, as you are finishing writing this down, you need to know something about me. I have a deep-seated hatred of the game basketball. Don't like it. Had a horrible experience in 3rd grade. Haven't recovered from it. I actually scored a basket for the other team. I know. Thank you for thinking. Yeah, it was a defining moment in my life. But with that said, guys, we all watch basketball. And we are looking at some of the most highly trained professional athletes on the planet. And guys, they spend hours and hours and days and weeks and months and years shooting free throws. Have you ever thought about that? It's probably the dumbest thing on the planet. It's always a line right here. It's always a basket up here. And guys, they make a living out of getting a ball from here to there. How hard can that be? Well, apparently it's hard enough that every single one of these athletes comes up with a rhythm. Have you noticed? Have you ever watched some triple dribble and then they spin it and then they sort of scratch their butt and then but guys, there's always a rhythm, right? Because we understand that rhythm leads to repeatability. And that's what it takes to shoot free throws, is doing the same thing over and over and over. Well, guys, this is your rhythm. You've got to get in this rhythm. This is your goal for today, is to develop this rhythm. And guys, the rhythm goes like this. Set your goal. Pick your starting point. Draw a line. Convert, solve, and round. That's your rhythm. If it's helpful to picture this, whatever it takes, this is your rhythm. So with that in mind, let's solve this. Ready? We're going to do this together. I'm going to do it with you. This is going to freak out my board, and you're just going to have to bear with me. Hold on. All right, so we're going to do this, and I'm going to do this in blue, and I'm going to do this a little bit thinner, and then I've got to jump back over here, and now I should be able to draw. All right, you guys ready to try rhythm? Let's try rhythm. What's step number 1? Look up in your notes if you need. Determine a goal. Guys, read the question. What are we solving for? Seconds. So we are going to do this with me. Skip down a couple lines in your notes. We're going to go all the way to the right. All the way to the right. And you're going to write down seconds. Now, guys, this. Step number 2 is we need a starting point. And guys, sometimes your starting points are hard to determine. So let me give you a strategy. And the strategy goes like this. Ask yourself this question. What determines the value that this is going to have? So guys, what determines how old you are in seconds? How old you are in years. Now guys, I know that Matthew is 18 as an outlier. Ami's 15 as an outlier. I'm going to use 17 as the average age in this room. If you would like to solve this relative to your own age, that's fine. Or if you would like to have a solution that looks like mine, pretend you're 17 if you're not. But guys, in either case, you are going to go all the way to the left, and you are going to write down your age in years. Now guys, again, I have to ask for grace because this is going to be a mess. What's step number 3? This is the best I can do. That's not bad. All right. Draw a line. Okay. Now, guys, at this point, we are now ready to engage in the process that many of you engaged in, but I heard Abby and Jesse talking about most specifically, which was the and then I, and then I, and then I, and then I. But what we're going to do is we're going to take all of those and then I's and we're going to string them across this line. And guys, this is the way to do it. What's step number 4? Conversions. But please read below that. Guys, what has to be true of these conversions? Fractions equal to 1, and they must cancel. So guys, let's talk about that. Join me at the board and let's think through this together. I have a question for you. How many seconds are in a year? Does anybody know? Then stop there. Guys, that's always the way to approach these problems. Ask yourself the question, how many of these makes up this? And we don't know, and that's fine. So then you ask yourself a second question. What can we break years down into that get us closer to seconds? What is a fraction? What is a fraction of a year that gets us closer to seconds? Days. Now let's stop there for a minute. Ami, you ask about weeks. Why are we not going to go to weeks? How many weeks are in a year? It's about 52. How many days are in a year? 365. So guys, we're going to do this as accurately as we possibly can. And because, it's not, if you do 52 times 7, it's not 365. And understand, you're fine. I'm just saying that's not the best way to get there because weeks in a year isn't quite accurate. So do you all know there are 365 days in a year? Do not write down what's about to go up on the screen. Actually, you know what? Is this animated in my slides? No, it's not, and that's good. Oh, shoot. You know what? Britt animated these. We're just going to keep going. Guys, do not write this down. But watch. 365 days is 1 year. Can I get an amen? Because you understand that just means we agree, right? Are we all in agreement that 365 days is a year? Okay, don't write this down, but watch. Here's the question. If this is true, then what are both of those fractions equal to? Why? You guys understand, right? Any number divided by itself is equal to 1. And so guys, if 365 days is equal to a year, then 365 days over a year is a fraction equal to 1. And if 1 year is 365 days, the other is also a fraction equal to 1. So both of those are fractions equal to 1. Here's the question. Which one are we going to use? Look at the second rule under Rule 4, Step 4. What does it say? Must cancel. And guys, here's what that means. Do this with me as soon as I get rid of this. Do this with me. Guys, draw a vertical line right there. And now, gang, here's what we're going to do. Look at where we're starting. We're starting in years. So if years are on the top here, years have got to be on the bottom because things in fractions cancel top to bottom. So we are going to put 1 year right there. Do that with me. And then guys, on top, we're going to put 365 days. Again, guys, we're learning process, right? Okay, now here's what we're going to do. We are going to cancel. Years cancel years. Now, guys, here's the question. And I don't even expect you to know the answer. Are we done? And the answer is no. Because if we stopped right there, we would be in days. But we are not done because, guys, days are not our goal. We're solving for seconds. So now what we do is we repeat the process. So we go like this. How many seconds are in a day? Does anybody know? Me neither. So what can we break days down? And this is going to start to speed up a little bit. Guys, what can we break days down into to get closer to seconds? Hours, right? Okay, so how many hours are in a day? Now, guys, do this. Let's not even do it on the board. Let's picture it. 24 hours, 1 day. Which one goes on the bottom? Why the days? because it cancels top to bottom. So can we go 24? No. Did you guys say days or hours? My bad. I did it wrong. 1 day is 24 hours. Now, guys, let's do the cancellation. Days cancel. We're left with hours. Again, the question, are we done? We're not, because we need to be in seconds. So now, guys, we just do it again. How many seconds are in an hour? I don't know. So what can we break hours down to? Minutes. How many minutes are in an hour? Which one goes on the bottom? There we go. So, guys, 1 hour is 60 minutes. Cancel hours. We're left with minutes. Are we done? We are not. So now, guys, we take the last step. How many seconds are in a minute? Hey, now I finally know. 60 seconds are in a minute. And so, guys, we are going to go 1 minute is 60 seconds. And our minutes cancel. We are now left with seconds. And we are done. Now, guys, grab your calculators. We are now ready to go on to step number 5, and we're ready to solve. Now, guys, here's the deal. The order of operations says that multiplication and division do not have a correct order. You can multiply first, divide first, it doesn't matter. You're going to develop a rhythm. This is my rhythm. If you don't want it to be your rhythm, that's fine. But guys, what I like to do is I like to start on the left, and I like to work progressively to the right. If you want to go all the way across the top and then all the way across the bottom, that's fine. That's not how I do this. So do it with me this time. Guys, take 17. And what we're going to do is we are going to multiply that by 365. Why multiply? It's on top. Multiply by 365. Now, guys, watch. What's on the bottom? A 1. That doesn't change the value, so you can skip it. Then we are going to multiply by 24, divide by 1, but it doesn't change the value. Then you're going to multiply by 60, divide by 1, doesn't change the value. You're going to multiply by 60, divide by 1, and again, it doesn't change the value. Now, guys, at this point, we are going to write down our answer. I'm going to clean up my mess just a little bit, just a second. I love that this actually feels like erasing. All right, so guys, we get 5, 3, 6, 1, 1, 2, 0, 0, 0 seconds. Guys, let's call timeout. Questions about the process? You okay? Because, guys, now this is about to get really interesting. Check this out. We need to have a conversation about what Michael and Cale talked about just a minute ago. And I don't even know if they understood the brilliance of what they said. But they were like, paraphrasing, but they said something like, as we're doing this, the answer just gets more wrong. Can you wrap your brain around that? Guys, how many of you are 17? Of you that are 17, how many of you are this old? The answer is none of you, right? Guys, think about this. Jessica's 17. And so if I walk up to Jessie and I go, hey, Jessie, how old are you? And she says 17. She's lying to me. She's not 17. She was 17 years old once. And that was January 12th at 8:32 in the morning. Because that's when she was born. And after that, she ain't 17 years old anymore. She's getting older and older and older and older and older. So guys, if somebody tells you that they're 17, what are they actually telling you? And the thing that they're telling you is they're not 18 yet. Yeah? So guys, the question becomes this. If 17 is an approximation, and it is, if 17 is an approximation, and I'll flip back. Oops, just a second. If 17 is an approximation, then this answer is inappropriate. So guys, let that tickle your ears a little bit. If this number is not accurate, then this number is not accurate. But guys, how do we as scientists communicate accuracy in numbers? Significant digits. Guys, do this with me. Ready? How many significant digits are in the number 17? 2. How many significant digits, and guys, you're going to want to do this. How many significant digits are in 365? Now, guys, watch this really quickly. Don't worry about the ones. All of your conversions will have a factor that's 1. That does not limit significant digits. It is merely a point of reference. So what we're saying is exactly 1 year is how many days. So that's the part that limits significant digits. So now let's keep going. Guys, don't look away. This is about to get weird. Watch. How many significant digits are in 24? No. Thank you, Joe. As if for emphasis, the drop of the pencil. Guys, the answer is not 24. Because think about what significant digits tell you. What do they tell you? Accuracy. So guys, do this with me in your head. How many hours are in a day? It's not a trick question. How many hours in a day? But is it actually like 23.9999997 and we just round to 24? No, it is stinking 24. And guys, because that's the case, this is infinite. Write it down with me. This is infinite significant digits. So now you're going, wait a minute. If that's infinite significant digits, let's go backwards. Is Jesse really 17 years old? No, so that's an approximation to 2 significant digits. But guys, what about 365? Is it actually 365 days in a year? No, it's actually more like 365.25. And what we do is we gather up all of those quarter days and we lump them together every 4 years and we extend our calendar by a day, and those are leap years, right? So guys, that is not accurate. It is actually 3 significant digits. So now let's keep going. 60 minutes in an hour, really? Yeah, really. Guys, it really is 60 minutes in an hour. That's infinite. 60 seconds in a minute? Yes. Also infinite. So now, guys, here's what we do. We round our answer to the fewest significant digits. So, guys, the fewest significant digits are 2, so we need to round this to 2. So here's 1 significant digit. There's 2 significant digits. What does the 6 tell us to do? Round up. And that would then make this number 540,000,000, which is actually 540 million seconds. So guys, if somebody tells you that they're 17 years old, the only thing that you know with any sense of certainty is they're about 540 million seconds old. Dang. But guys, again, coming back to the idea, do we care? We don't. We don't really care at all how old you are in seconds. What we care about is all of this, right? So guys, as you are working on mastering this, we're going to do 2 more. And as you're working on homework, you're keeping your eye on Tuesday. You don't care about the answers to these questions. You care about getting them right, because on Tuesday, you're not going to be able to do these in your head. So guys, let's pause. Any questions about the process? Set a goal, pick a starting point, draw a line, convert until your units cancel to leave you with the answer, multiply by the top, divide by the bottom, and then round to the least accurate factor. Good? Okay, let's do another one. Do this with me. Oh, wait a second. All right, hold on. I want to do this, and I want to do this, and I want to do this. Okay, guys. Don't write down the question, but read with me. I'm going to kick you out of the nest a little bit. It says if Larry weighs 100... Why do I like the name Larry? If Larry weighs... Do any of you have a friend named Larry? Who? Introduce me. I like Larry. It harkens back to VeggieTales, and it makes me happy. So guys, if Larry weighs 125 pounds, what is his mass in grams? Can we just say together we don't care? And then can we solve it? Guys, here's what I want you to do. Kicking you out of the nest a little bit. Do step 1 without me. Set your goal. And remember where it goes, all the way to the right. And then would you please do step 2 without me? Starting point. And then would you please do step 3 without me? Which is draw a line. And then guys, I'm going to try this. I've never done this before. It's really ironic, but Miss Call, when she does calculations with her students, animates all of her slides because she thinks her handwriting's bad. Compared to me, she looks like a calligrapher. But I'm going to use her animations. And when we're done with this, would you please, I'm going to ask you for feedback about whether this is better or not. Let me catch up with you. So guys, this is where I'm at. Our goal is grams, yes? Did you all get that? If you didn't, would you fix it? And then guys, off to the left, our starting point is 125 pounds because the weight in pounds will determine the weight in grams. And then we drew a line. Yeah? Now guys, at this point, we're ready for step number 4. We're going to draw a vertical line right there. May as well do it together. Now guys, step 4. We ask ourselves this question. How many grams are in a pound? And we don't know. But guess what I have for you? A conversion chart. So guys, this is fair game for the rest of the year. You know how every day starts with me saying grab your periodic tables and your ion charts? Now it's going to be grab your periodic tables, your ion charts, and your conversion charts. So guys, let me give you about 20 seconds to scan this, and then we are going to doctor this up so it's more useful to you. So guys, first of all, let's be a little metacognitive about this. Let's think about what we're thinking about. What in this paper draws your eye to the way that it's organized? See the stuff that's underlined? Guys, underline tells your brain organization, but so should spacing. You'll notice there are things that are underlined and then those things are set off by spaces. That tells your brain organization. So guys, let's talk about the organization vertically. It goes English, metric, and English to metric conversions. But how is it organized left to right? We've got length, volume, and weight. So guys, do this with me. Let's start at the English system. You ready? Starting in length. 12 inches is a foot. Is that true? Really true. Guys, middle. 2 cups is a quart, or 2 cups is a pint. Is it really 2 cups is a pint? Is it close or is it that? It's that. Guys, on the right, 16 ounces is a pound. 15.9 and we round it, or is it 16 ounces is a pound? What does that tell you about all the English conversions? They're perfect and therefore infinite significant digits. You may want to write next to English conversions, perfect. These are all perfect. Then guys, in the middle, whoa, metric system, length, volume, and weight. First one, 100 centimeters is a meter. Really? Yeah, really. Guys, center column, 1,000 centimeters cubed is a decimeter cubed. That's a definition. Guys, off to the right, 1,000 milligrams is a gram every stinking time. What are you going to write next to metric? They're perfect. All of them are perfect. Now guys, do this with me. English to metric conversions. Length. Look at the second one. A meter is 39.37 inches. No, it's not. It's close. Guys, go to the middle one. A liter is 1.06 quarts. Kind of. And then off to the right, a kilogram is 2.2 pounds. Sort of. So guys, what about all the English to metric conversions? They are not perfect. I'd encourage you to write that down. And consequently, they do limit significant digits. with one amazing exception. Which one? Do you see it there? An inch actually is perfectly 2.54 centimeters. I have no idea why that happened. But guys, it is perfect. And you'll notice next to it I wrote exact. Yeah?
That's because we decided that in like the 70s to base the English system off the metric, and so we changed the sign that it should be exactly 2 centimeters.
Really? Because I knew that the inch existed before. David, I would want to learn more about that, because you're right that in the 1970s we switched to the metric system and then we switched back. Although technically we are still on the metric system, and at that higher level we convert. So all of our English standards are based on metric standards and we convert. But the inch and the meter existed before that change. And I'm not doubting you, but I am questioning, because what you're saying is that in 1972, the length of an inch changed. And the ramifications of that are huge, because then the yard and the mile would change. I would love to learn more about that. I'm not saying you're wrong, but I'm a hint skeptical. But I'd love to learn more. Find me a link and email it to me, would you? Yeah, okay, not now. But okay, so guys, do this with me now. Join me again, and let's figure this out. Guys, check this out. How many grams are in a pound? Well, now we have a resource, don't we? But guys, here's the thing. There is nothing on here that says grams in a pound. So this is going to be a multi-step conversion. So what can we do with pounds to get it closer to grams? Say it again. Good for you. We could go pounds, and I'm just going to sort of finger through it. We could go pounds to ounces and ounces to grams. But that's not the only way to make the trip. What's the other one? Pounds to kilograms and kilograms to grams. Now guys, please hear this. Which one's better? Doesn't matter. It doesn't matter. And two significant digits to the correct number of significant digits, our answers are going to be the same. So guys, if you'd like to do this the way that I'm going to do it, we are going to go pounds to kilograms. So guys, there are 2.2 pounds in 1 kilogram. So now what do we do next? We cancel. And so guys, pounds cancel with pounds, and we are now in kilograms. Again, guys, we're developing process. Are we done? We are not done. So now what we need to do is we need to go kilograms to grams. Guys, how many grams are in a kilogram? Find it on your paper. 1,000 grams. Now guys, and if it's helpful to watch my hands, watch. 1,000 grams is a kilogram. Which goes on the bottom, the kilogram or the grams? Kilograms. So guys, we are going to draw a line, and we're going to say 1 kilogram is 1,000 grams. Now our kilograms cancel, and we are now left with grams. And so guys, at this point we need to do the math. But guys, check this out. Watch. Just join me for a minute. I'm finding that I hate the animations. I'm done with this. Just a moment. This is going to freak out. Hold on. I'm not loving this. Okay, let me see if I can write. Okay, good. All right. So, guys, coming back to doing this live, we are in grams. How do we know that we're done? Good for you. Because this is that. So, guys, we're done. So now we do the math. Would you grab your calculators, but go slow with me? Guys, we're going to start with 125. Now guys, watch. Again, we're multiplying by the top and dividing by the bottom. Why do we not multiply by 1? Doesn't change the number. But guys, now be careful. We have to divide by 2.2. Now we multiply by 1,000, and we do not divide by 1 because that doesn't change the number. Now at this point, we write down our answer. And I get 56818.18. grams. But we're not done yet, are we? What do we need to do next? Last. Round. So guys, go with me to the left. How many significant digits are in 125? 3. Guys, picture this. And this is a really interesting point. Picture Larry in his underwear, stepping on the scale. And Larry looks down and it says 125. Does he really weigh 125? Depends on how good the scale is, right? What's not? Brilliant. And those will always be your starting points. Guys, don't miss what Michael just picked up on. This number will never be perfect. Why? Because it's always a measurement. Guys, the only things that can be perfect are conversions. That number will never be perfect. Do you understand why? It's always a measurement. Now let's keep going. 2.2 pounds is a kilogram. Really? No. Kind of, but not really. It's an English to metric conversion, and therefore it's imperfect. So guys, we ignore the 1 because that's our point of reference. This is 2 significant digits. Now guys, let's look at the next one. 1,000 grams is a kilogram. Really? Oh yeah. That's a definition. That is perfect. Then guys, we round to the fewest significant digits. In this case, that would be 2. And so this is 1, this is 2. The 8, just a moment, tells us to round up. And so this would be 57,000 grams. David, just a moment. Questions, thoughts, or concerns? Yeah.
Just when you were putting like the 1 kilogram over 2.6 pounds.
Mm-hmm.
1,000 grams over 1
Yeah.
How do you decide like what is
Yeah, I love that you're asking that question because you're thinking about process. Let's talk. So guys, Kimball's question is, how do you know how to orient these conversions? And Kimball, the answer is actually, forgive me, it's actually really beautifully simple. And it just goes like this. If this is pounds, then that has to be pounds. If this is kilograms, then that has to be kilograms because they always cancel top to bottom. Every single time. Go, Bree. Yeah. Good for you. And David, that's what you wanted to talk about as well, right? Let me answer that for you. So, and I love that you did some solo work, and David, you as well. Guys, Bree and David are asking the question, what if we did it the other way? I'm just going to do this, and I'm going to do this. So, guys, the answer to this... Oh, I did it. The answer to this was, what, 57,000? Okay, guys, watch really quickly. What if we did it the other way? And I'm just going to do this very hurriedly, but it would go like this. 1 pound is 16 ounces. Frighteningly, I know that 1 ounce is 28.4 grams. And you would be done right there. So let me do that math really quickly. So we would go, so 125 times 16 times 28.4. This gives us 5, 6, and 800. But guys, watch this. This is interesting. How many significant digits are in 125? 3. How many significant digits are here? Infinite. This is perfect. How many significant digits are there? That's not perfect. This is 3. Now, guys, remember previously this was 3, 2, and perfect. Now we've got 3, perfect, and 3. So how many significant digits do we get if we do it this way? We get 3, which is this. So it turns out that the bottom answer will actually give us an additional significant digit because the conversions are more accurate. So David and Bree, if you did it this way, the correct answer would be 56,800 grams. Is that okay? Okay, yeah, please, Jasmine. Mm-hmm. No, actually, so, sorry, yes. And it's actually the bane of my existence because there are multiple ways to solve all of these problems. And when I do the keys, like for the test, I have to account for all of them. It's a little thing I like to call horrible. What you are going to see, though, Jasmine, is on the homework, I had to commit to one, right? And so if you did it a different way, you'll probably get good at enough at this that you can look at it and go, yeah, I'm okay, even though I did it different. If not, come and ask. Okay, all right. So, guys, I just made an executive decision. There's one other thing that I wanted to expose you to today. But guys, honestly, driving to school this morning, I wasn't even sure if I was going to make it to school, let alone be able to teach. And so I started thinking through this morning, how could I make this more compact? And so guys, what I've chosen to do is I am not going to teach you the last layer to this onion. There's one other thing that you need to know about these. And now you're going, wait, if you're not going to teach it to us, it must have either not been important or... Because the other skill that you needed to have, you don't need until the next unit. It doesn't come up. And so consequently, I'm not going to teach it to you now. I'll teach it to you then. So what does that then mean? So guys, let's pause. Any questions about any of this? Okay, then let me bring you back. Guys, remember your goal for the day. We don't care what Larry weighs in grams. We care about knowing how to figure out what Larry weighs in grams. So it's all about process. So guys, here's what you're going to do. Grab your homework packets. Jasmine, do you need one? You got one? Does anybody else need one? Were you gone last time? You didn't get your test back. Okay, we can work on that. So guys, turn to assignment number 2. And draw a line between numbers 20 and 21. Guys, 21 and down represent the questions that you cannot answer because we didn't do the last problem. And that's just going to have to be okay. So guys, what we are going to do is this. We are going to do 1 through 20. Sorry, I'm scanning here. So guys, let's do this. We are going to do 1 through 20, the evens, not odds. Don't do that backwards because I was just looking through the problems and there are examples of things that show up in the evens that are not in the odds. We're going to do the evens. So when we see this on whenever I see you again, to say yes to the question, you did it completely, you need to have completed the evens. But guys, let's be hyper clear about this. This is not optional. Grab probably 2 at least sheets of notebook paper, and you are going to do all of these on another sheet of paper. If I see that you solve these on the homework packet paper, I will not allow you to turn them in. I'm not going to let you do that to yourself. You need space to write big. You need room to solve these well. And again, guys, as you're working through these, your question to yourself is, am I learning the process? Because guys, when I see you next time, you need to know the process. If you need help on these, please ask. Guys, I make them look easy. They're not as easy as I make them look. So we're going to start right now. You should get at least 2, 4, and 6 done before you leave. I'm going to stop recording. I'm going to put the answers up on the wall. And the remainder of the time is going to be yours to work on.